Yes, good evening everyone. Please turn on your video before we start the class. Okay, very good. So, as on the screen, we'll be starting with a new topic today. Myself, let me introduce you myself first. My name is Amit Miriala. Okay, I'll be your mathematics teacher. Okay, and today we are going to start with a new topic that is quadrilaterals. Fine. So, let us understand what is quadrilateral first. So any shape which has four lines, four straight lines will be said as a quadrilateral. That means like this. Suppose if you have any shape. First of all, you know that what is polygon? Do you know what is polygon?
Closed figure.
Any closed figure which has more than three sides or equal to three sides will be said as a polygon. Means the first polygon means if you have a three sides, then that polygon will be said as a triangle. Okay, then that figure will be said as a triangle. Now if it has a four sides, then it will be said as a quadrilateral. If it has four straight lines, if it is a closed figure, if it has five sides, then
Pentagon.
yeah,
Pentagon.
it will be pentagon, right? And similarly there will be hexagon, octagon and so on, right? So today we are going to study about the quadrilaterals first, which has only four sides. Okay, now in quadrilaterals also you have different types. Now, the first thing in a quadrilateral, what is the angle sum property in a quadrilateral? Suppose if you take any quadrilateral, if you try to draw this quadrilateral like this, okay, if you draw any quadrilateral, this is any type of quadrilateral. Now, what you can see, you can take your degree, try to measure all the angles, try to measure all the angles. What you will get ultimately, if you add all the angles, the answer will be 360 degree. That means if this is A, B, C and D, and if you add all of them, angle A plus angle B plus angle C plus angle D, what you will get, that will be always 360 degree. It can be any type of four-sided closed figure. Always it will be 360 degree. Okay, as you know in triangle it is always 180 degree. Now why it is like this? It is always 360 degree. Can anyone tell what will be the reason why it is 360 degree? Suppose if I am drawing any a diagonal in this quadrilateral. Okay, what I am doing? I'm drawing a diagonal in this quadrilateral. Now I know that angle sum property of a triangle is always 180 degree. That means this, if I say A, B, C, I know that A plus B plus C is always how much? How much it is?
180 degree.
180 degree. Similarly, I know that D plus E plus F will be always equal to 180 degree, right? So if I want to find what is the sum of all the angles in the quadrilateral, this B and F will be added, no, and C and D will also be added. If I add all of them, it will be 360 degree. Understood?
Yes.
Yeah? Okay, fine. So this is the reason why the angle sum property is 360 degree in a quadrilateral. Fine. Now there are different types of quadrilateral. This is what your quadrilaterals. Fine. What are this? It is a quadrilateral if it has two parallel sides. Suppose if it has two parallel sides and the other two sides are not parallel. Okay. Then what we can say? It is a trapezium.
Trapezium.
Fine. If this side SR, if this side is parallel to this side and this side is parallel to this side, then what we can say? It is what?
Parallelogram.
Parallelogram.
Parallelogram. This, in this also, if this side is parallel to this and this side is parallel to this, or we can also say that is this side is equal to this and this side is equal to this, and any one angle is 90 degree, then what we can say? It is what? Rectangle.
Rectangle.
Fine. Similarly over here, all the sides are parallel, but over here all the sides are equal also. All these sides are equal also. Then what we can say? It is a rhombus.
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 Over here all the sides are equal, but one of the angle is 90 degree, then rest all of them has to be 90 degree. That's why we can say it as a square. Over here it's a kite, where these two adjacent sides and these two adjacent sides are equal, and the diagonals of a kite are what? Perpendicular to each other. Fine, they do not, only one diagonal bisects. This side is equal to this side, but this side is not equal to this side. Fine. Further, the next thing is, there are something which you should know. See over here, this thing. A square is a rectangle and also a rhombus. How we can say? How a square can be?
Because its opposite sides are equal and also one of the angle is 90 degrees, so it is rectangle.
But how a square can be said as rhombus?
All sides are equal.
All sides are equal. To be a rhombus, what is the requirement? To be a rhombus, the requirement is all sides should be equal. That's it. And opposite sides should be parallel. That's the only requirement. That is there in the square also. So that's why a square can also be said as a rhombus. But can a rhombus can be said as a square?
No,
Why?
No.
all angles are not 90.
Exactly. All angles are not 90. A parallelogram is a trapezium. Why we can say? Because to be a trapezium, only two sides, two opposite sides should be parallel. So in a parallelogram, two opposite sides are already parallel. The other two sides are also parallel, but that's not required in a trapezium. So what we can say, a parallelogram can also be said as a trapezium. But a trapezium cannot be said as a parallelogram. Fine. Next. A kite is not a parallelogram. Why?
Both sides are not parallel.
Opposite sides are not parallel. Yeah. Opposite sides are not parallel in this. A trapezium is not a parallelogram. Fine, we have already understood. A rectangle of a rhombus is not a square. A rectangle or a rhombus cannot be a square. Fine, we have already understood. Okay, next. There are some properties of parallelogram. Also, you will be having theorems. You have proofs to solve. Means you have proofs. You have to do proofs, or you don't have to do proofs. What they
We
said in
have
your
to
school.
do.
We have to
You
do.
have to do proofs, right? Okay, fine. So first of all, we'll go to the first theorem of parallelogram. The first theorem, what it states. See over here. The first theorem states that a diagonal of a parallelogram divides it into two congruent triangles. Suppose if I take any parallelogram like this, okay, what they are saying, the diagonal of a parallelogram divides it into two congruent triangles. Suppose if I'm making a diagonal over here, okay. Now in this theorem, what is given? What is given in this theorem? They have given, that is, we can say, that is, if this is ABCD, what we can say? Quadrilateral ABCD is a parallelogram, is a parallelogram. That's the only thing which is given. Yeah. After that, what you need to prove in this? What you have to prove? That triangle ADB is congruent to triangle CBD. This is what you need to prove. Right? Now let us write the proof. How we can prove it? See, we know that this line is parallel to this line. Right? Then this angle will be equal to this angle, yes or no? Yeah. So what we can say,
Yes.
Yes.
in triangle ADB and triangle CBD. Okay, what we can say, angle ABD is equal to angle CDB. Wait, angle ADB and CBD. Yeah, this will be CDB. Yeah, these two angles are equal. Yeah, fine. Why they are equal? They are alternate angles. Yeah, what is the property? By alternate angles. Since these two lines are parallel, so these two angles will be equal. We also know it is a parallelogram, so this line will be parallel to this line. So can I say this side, this angle is equal to this angle by alternate angles? Yeah. So what I can say,
Yes.
angle ADB is equal to angle CBD. I can say this. Fine. Now this is also by what? Alternate angles. By the property that is they both are alternate angles. Also in both this triangle, can I say that BD is equal to BD because that is common in both the triangle?
Yes.
Yeah, BD is equals to BD. So that is what they both are common. So now what I can say, see these two angles are same and the side is same, right? The side which is in between the two angles. So it is same. So what we can say that the two triangles are congruent by ASA test. Yeah.
Yes.
Therefore what I can say, therefore triangle ADB is congruent to triangle CBD by ASA test of congruency. Yeah, I can say this. So the two triangles are what? Congruent by ASA test of congruency. Clear? So that's what they have to prove. They said you to prove triangle ADB is congruent to triangle CBD, and it is proved. Is that clear?
Yes.
Yeah. And everyone over here, you will be getting a PDF notes of this after the class. Okay, if you want to write this as a note in your notebook, you can write down, no problem. But anyway, even if you don't write it, you write it, that is preferred that you should write. Okay, but even suppose if you are not if you were not able to write it due to the speed of the lecture, so no worries, you can take the notes after the class. Okay, next, this was the first theorem. Now the next theorem is this: in a parallelogram opposite sides are equal. See, in a parallelogram, what is the condition to be a parallelogram? Only the opposite side should be parallel. Now what you have to prove? That the two triangles are sides are equal. Again the same thing, the same proof it will be. It will be again the same thing. This all thing is given. Okay, including all this thing, we have already proved that is the two triangles are congruent. Now since the two triangles are congruent, then their corresponding sides will be equal. Yes or no? Yeah.
Yes, sir.
So therefore AB will be equal to CD. Therefore
Yes.
AB will be equal to CD by CPCT, corresponding parts of congruent triangles. Understood? Then the opposite sides are equal, and proved. Now over here, what you have to prove is, the proof will change. The proof is AB is equals to CD. This is what you have to prove. Understood? Clear?
Yes.
The next theorem. The next theorem, what it states, if each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. Now over here, what you have? It is not said that it is a parallelogram. We don't have the information it is a parallelogram. But what we have the information, that is if this is ABCD, what they have given, that is the given is AB is equals to CD. If each pair of opposite sides of a quadrilateral is equal, that means AB is equals to CD and AD is equals to BC. This is what is given. Now you have to prove that it is a parallelogram. How you will prove it? Okay, again, for this we will draw some construction. That is, first what you have to prove, then we'll do the construction. What is to prove? To prove is ABCD is a parallelogram. This is what you have to prove. And now there will be some construction in this. What is that construction? You can draw any one diagonal, join, we can say join BD. Okay, so let's join this length BD. Is joining done? We have joined it. Now what we know, that this side is equal to this side and this side is equal to this side. Again, what we will know, since AB is equals to CD, that is given. Yes or no? Again, AD is equals to BC. Again, this is also given. Are you getting it, everyone over here? Please raise your hands
Yes,
if you are
sir.
getting everything. Please raise your hands like this. Yeah, very good. Fine. Okay. Also, we know that BD equals BD. Why? Because they both are common. They both are common. Now over here, all the corresponding sides are equal of the two triangles. Then what we can say that the two triangles are what?
Congruent.
Exactly. Triangle ABD is congruent to triangle CDB. Now once the two triangles are congruent, then what we can say? Then their corresponding angles are equal. Yeah,
Yes,
yeah. This two triangles are similar, congruent by what? By SSS test of congruency. Okay, by SSS test of congruency. Now once you know that the two triangles are congruent by SSS test of congruency, then their corresponding angles will be equal. Then what we can say that this angle is equal to this angle. Yeah, therefore angle ABD is equal to angle CDB, right? Angle ABD is equals to angle CDB by which property?
CBCT.
CPCT, right? They are by CPCT. Now, if these two angles are equal, then what we can say about the two sides, that is AB and CD? Therefore,
They are
AB
parallel.
is parallel to CD, right? And similarly, I can say AD is parallel to BC, then I can say it is a parallelogram. Similarly, you can write, similarly, AD is parallel to BC. Therefore, quadrilateral ABCD is a parallelogram. Clear? Yeah?
yes,
Okay, fine. The next theorem which you will have is the next statement is this. But before I do it, I want you to try it on your own. Yeah, please try it on your own. I'll be back in a minute. Yes? Did you solve it?
Yes.
How did you get it that the opposite angles
solved.
are equal?
Sir, I drew a diagonal and then I proved the two triangles congruent.
Hmm?
And then by CPCT, the opposite angles would be equal. And
Yes,
if we
perfect.
draw the other diagonal, then
Yes,
the two
the two
angles will
angles
be
will be equal. Perfect. Very good. Understood, everyone? Anyone has any doubt? No doubt, no?
No,
Fine,
sir.
fine. So in this, all the means all the proofs will be done by using one diagonal or the two diagonals. Prove that the two triangles are equal, and you'll get the proof. Okay, almost all the proofs. The next is this. That is, if in a quadrilateral, each pair of opposite angle is equal, then it is a parallelogram. It is just the converse of this, the same way. But how do you do it? Do you have confusion in it?
equal. Can you explain?
Yeah, fine. See again, I'm drawing a parallelogram, but I don't know whether it is a parallelogram or not. I don't know this, right? And suppose if I'm drawing a diagonal also to this, what I know in this, that if in each pair of opposite angles are equal, I already know that this angle is equal to this angle and this whole angle is equal to this whole angle. I already know this. Fine. Now, then it is a parallelogram we have to prove. Fine. Suppose I have drawn this diagonal. I don't know that it is a parallelogram. Fine. Each pair of opposite angle is equal. Then it is a parallelogram. Opposite angles are equal. Just a moment. If in the quadrilateral each pair of opposite angle is equal, then it is a parallelogram. You will not have a proof of this. You don't have a proof of this. You can only study it as a statement. Okay? You will not have to prove. The proofs which
Sir,
we,
but
yeah,
we know na that opposite sides of parallelogram are equal.
opposite sides of a parallelogram are equal. Yeah, we know that. But over here, we are not knowing that it is a parallelogram.
Okay.
Yeah, we didn't know that it is a parallelogram. So also, if you don't have the proof of this, how we can prove it? But you can remember it. In a quadrilateral, each pair of opposite angle is equal, then it is a parallelogram. That means if this angle is equal to this and this angle is equal to this, then what we can say, it is a parallelogram. You don't have the proof of this, not even in the textbook. Okay?
Uh,
Yeah.
but if we take the opposite sides as equal, then we can prove by SAS.
But we don't know that opposite sides are equal. How we can take the
The
opposite side?
property of parallelogram.
Again, it is not a parallelogram. Means to do this
Okay.
theorem, it is a quadrilateral. No, it is not a parallelogram. We only know that the opposite angles are equal.
Okay.
Yeah. Okay. The next, the diagonals of a parallelogram bisect each other. Yeah, this if they ask, you will have to prove it. They may ask. That is, the diagonals of a parallelogram bisect each other. Bisect each other means, suppose if I draw a parallelogram, okay, the diagonals are bisecting each other. That means if I draw the diagonals, what you have to prove in this, that the diagonals are bisecting each other. That is, if this is A, B, C, and D. Now, what is given in this case? The given thing is quadrilateral ABCD is what? Is a parallelogram. Yeah? And what you have to prove is, suppose if O is the point of intersection, what you have to prove? AO is equals to OC. That's what you have to prove. Also, you have to prove BO is equals to OD. This is what you have to prove. Getting it? You have to prove this. Now, how you will prove? If I want to write the proof of this, see, I'll take this figure. I'll take it down. Now, it's a parallelogram. We already knew it. Now, in triangle AOB and triangle COD, what all things you have? You know that this angle is equal to this. Yes or no? Also,
Yes.
you know that this angle is equal to this angle. Yeah. You also know that
Yes.
Yes.
this angle is equal to this angle. Again by alternate angles. Also, you know that this AB is equals to CD. Why? Because it's a parallelogram. Opposite sides are equal. Then we'll write it over here. Angle BAO is equals to angle CDO. Sorry, DCO. Why? Alternate angles. Again, angle ABO is equal to angle CDO. Again, alternate angles. Also, AB is equals to CD. Why? Because quadrilateral ABCD is a parallelogram. In a parallelogram, opposite sides are equal. Yeah, it's a parallelogram. Then what we can say? Therefore, triangle AOB is congruent to triangle COD. By which test? Tell me. By which test? They are equal. They are congruent.
ASA.
Perfect. They are congruent by ASA test of ASA test of
Uh,
congruency. Yeah.
so we can also prove by AAS
No.
if we take vertically opposite angles
Yeah, you can do
and
that
only
also.
one
Yeah.
alternate
Yeah.
angle.
Yeah. That can also be done. Yeah. Therefore, the two triangles are what? Congruent by ASA test. Right. Once the two triangles are congruent, then what we can say?
AO equal to C.
Yeah. Therefore, AO equals OC by CPCT. Yeah. By CPCT. That's what is required. Also similarly, BO is equals to DO. Again the same by CPCT. Clear? Why the diagonals are bisecting in the parallelogram? Yeah.
Yes, sir.
The next. The next is just the converse of this. Yeah. Over here, what they have given. If the diagonals of the quadrilateral are bisect each other, then it is a parallelogram. What we done just before? If the diagonals of a parallelogram are bisecting each other. If they are bisecting each other, then it is a parallelogram. It is just the converse of that. Yeah. The next thing which you have is, yeah, that's done with the theorems. No, you have one. Yeah, one more thing. One more theorem you have. Okay. Now the next thing what you have over here, a quadrilateral is a parallelogram if a pair of opposite side is a equal and parallel. Right? This can also be if a, okay, well, let's do it. A quadrilateral is a parallelogram if a pair of opposite side is equal and parallel. Suppose if I am drawing a parallelogram, I don't know whether it is a parallelogram. Okay. Now see, a quadrilateral is a parallelogram if a pair of opposite side is equal. Suppose in this two, if these two opposite sides are equal, suppose this is equal to this and this is also parallel to this, then we have to prove that it is a parallelogram. How do we prove? Again, if I draw a diagonal to it, to this quadrilateral, I don't know it is a parallelogram, yes or no. Okay. Now in this, what I can say, this angle is equal to this angle by which? By what? Alternate angles. Yes or no? This side is equal to this side already given. And this side is equal to this side. They both are common. So what we can say? That the two triangles are congruent by what? SAS
SAS.
test. Right? And if the two triangles are congruent by SAS test, what we can say? All the corresponding angles will be equal. That means this angle will also be equal to this. Yeah, what I can say, that is this angle will be equal to this. Now if this angle is equal to this, then it will be parallel, these two lines will be parallel by converse of alternate angles. Understood? You want me to write this or you have understood? Please tell in the chat box or verbally, anyhow anything is fine.
Sir, so the second pair of alternate angles will also be equal. So that is why they are parallel.
Yes.
So I
See,
understood.
yeah, if you draw a line and if this line, if this angle is equal to this line, then what we can say? These two lines are parallel, simple. By converse of alternate angles. Yeah, understood? Clear? We'll go to the next. So over here we are done with all the theorems which you have. Okay, in this chapter, that is quadrilaterals. Now we are going to start with your exercise. Okay,
The theorem 9 and 8 is remaining.
what theorems? What?
The two theorems are still remaining.
Which two theorems are remaining?
Sir, they are there in page number 148.
One,
48.
page number 148. Okay. Yeah, page number 148 comes after midpoint theorem, you are saying? Yeah,
Yes, sir. In
yeah,
theorem.
yeah, that theorem will come after your first exercise. We'll have to do the first exercise first. Then will means I said that before first exercise, whatever you have, the theorems, that is completed. Okay?
Okay, sir.
Yeah. Now, this is what the first exercise which you have. That is 8.1. Now, let's try to solve this. Now, over here, what you have, they have given the angles of a quadrilateral are in the ratio 3 is to 5 is to 9 is to 13. Then find all the angles of the quadrilateral. This is a very easy question. What you can do, we can just draw any random quadrilateral like this. Okay, and they have given the ratios of all the quadrilateral. Let us take, that is, this is 3x. They are all in ratio, no? So I can say this has 3x, this has 5x, this has 9x, and this has 13x. What I know, the sum of all angles in the quadrilateral will be equal to how much? 360 degree.
360.
Yeah. So angle sum property of a quadrilateral, that is 3x plus 5x plus 9x plus 13x equals 360 degree. What is the property? Angle sum property of quadrilateral. Angle sum property of quadrilateral. Fine. After that, you add all of them. 3 plus 5, 8, 8 plus 9, 17. 17 plus 13 is how much? 30. So 30x equals 360. So x will be equal to 12. Now, once you get the value of x, you can get all the values. Find all the angles in the quadrilateral. Let's say this is A, this is B, this is C, and this is D. So angle A will be, angle A is equals to what? 5x. So 5 into 12. So angle A is 60 degree. Angle B equals how much? 13x. 13x. Then it will be 13 into 12. 13 into 12 is 144 plus 12. That is 6. 156. Clear? Yeah. Similarly, angle C will be equal to 9x. That is 9 into 12. That is how much? 108. Yeah. And angle D equals how much? 3x equals 3 into 12. That is 36. You add all of them, you will get 360. Yeah. You can take a try. Yeah. If you add all of them, the sum of all the angles will be 360. If the sum of all the angles is not 360, that means there is something wrong which you have done. It has to be 360 in the quadrilateral. Clear? The next question, what they have given? If the diagonals of a parallelogram are equal, then show that it is a rectangle. Again, you will have to do it with two similar triangles only again. So I'll not solve this completely. I'll only verbally explain how to do it. If the diagonals of a parallelogram are equal, then show that it is a rectangle. Now, whenever you have a proofs like this that show that it is a rectangle, so it has to be a rectangle only. While drawing it, draw it as a rectangle only. Don't draw it as a parallelogram. Even if they have given if the diagonals of a parallelogram are equal, so do not draw it as a parallelogram because the diagonals will not come equal if you draw a parallelogram. Yeah. Now what you have, the diagonals of the parallelogram are equal. That means if you draw these two diagonals, the diagonals of the parallelogram are equal, then you have to show that it is a rectangle. Yeah. How you will prove it? Consider this is A, B, C, D. Now what all things are given in this? What is given? Quadrilateral ABCD is a parallelogram. This is what is given. Yeah. After that, what they have given? Nothing else. Then show that it is a rectangle. If if the diagonals of the parallelogram are equal, they have also given the diagonals are equal. So this is what the first condition. The
AC
second
equal to
condition given
BD.
is AC is equals to BD. This is what is given. Now what you have to prove? What do you have to prove in this?
Triangle ADC
ABCD
is
is
equal to
rectangle.
angle is equal to triangle BCD.
Mm, you have to
Triangle
prove it is the
AC
quadrilateral ABCD is a rectangle. You have to prove. Now a quadrilateral, a parallelogram, when it will be a
So,
9 will be a, what? Yeah, what?
so they have given common sides also.
What? I
So
still
they have given common side also.
common side where they have given
If AB is equal to BA,
AB is equals to BA. Acha, acha, maybe that will be in the triangles which we will consider. Yeah. I was asking what we have to prove. Now to prove it, what we will do? In this, if I take this
Sir, we
try
will take
We
a
can take
triangle
triangle
ADC
ADC and
and
BCD.
A,
yes, sir.
acha, ABC and
ADC and
ADC,
BCD.
BCD, ADC and BCD. Yeah, fine. You can take that triangles. Now in triangle ADC and triangle ADC and BCD, what all things you have?
DC is
AC,
equal to
AC is
CD.
equals to BD, given. This is what is given. After that, DC is equals to DC. Why? Common. And AD is equals to AD is equals to BC. Why? Opposite sides of a parallelogram. Why? Opposite side of a parallelogram. We know already that it is a parallelogram. We only have to prove that it is a rectangle. Now, since the two triangles are congruent, therefore, triangle ADC is congruent to triangle BCD. Now, if the two triangles are congruent, what we know? That is angle ADC will be equal to angle BCD.
Yes.
Yeah. But what do we know? If see, it's a parallelogram, right? These two lines are parallel, no? Then angle ADC plus angle BCD should be equal to 180 degree.
Yes,
Why? They are interior co-interior angles.
Co-interior.
Yeah. That is angle ADC plus angle BCD is equals to 180 degree. Why? Co-interior angles. Interior angles. This is what you have. They both are co-interior angles. But angle ADC is equals to angle BCD. So therefore, angle ADC plus angle ADC equals 180 degree. ADC plus ADC is twice of angle ADC equals 180 degree. So angle ADC will be equal to 90 degree. Yeah, what you have? Angle ADC will be equal to 90 degree. Now, in a parallelogram, if any one angle is 90 degree, then what we can say? All the angles will be 90 degree. Yeah. Therefore,
Yes.
therefore, what we can say? Quadrilateral ABCD is a rectangle. Is that clear? Yeah,
yes, sir.
it's done. Show that if the diagonals of a quadrilateral bisect each other at right angle, then it is a rhombus. Again, the same way. Show that if the diagonal, see, I'll orally explain this, I will not write it. Show that if the diagonals of the quadrilateral bisect each other at right angles, then it is a rhombus. Yeah. Now what if they have given? Show that if the diagonals of the quadrilateral bisect each other, that means these diagonals are bisecting. This is equal to this, and this side is equals to this side. Now again, if I consider A, B, C, and D, if I say AOB and DOC, AOB and DOC. What do you have? These two sides are equal, and also the angle is equal. Therefore, the two triangles are congruent by SAS test. Yeah. Now, once the two triangles are congruent, then what we can say? All the
AB
corresponding
equal to
angles and
CD.
yeah, AB will be equal to CD. Also, this angle is equal to this angle. So, if this angle is equal to this angle, these two lines are also parallel. Then, yeah, this side is equal. No, show that the diagonals of a quadrilateral bisect each other at right angle. Then it is a rhombus. Acha, diagonals bisecting each other at right angle. Oh, they are saying if it is if the diagonals are bisecting at right angle, then it is a rhombus you have to prove. Fine. Over here also the same. AOB will be equal to COD and the two triangles will be congruent. The two triangles will be congruent. That means if this angle is equal to this, fine. After that, if you take these two triangles, this triangle and this triangle, what do you see? What do you see in this? This side is equal to this side is equal to this side, this side is equal to this side, and these two angles are equal. Then again, you can say that the two triangles are congruent by SAS test. Now, if this triangle is equal to this angle and this is a linear pair, so this angle plus this angle will be equal to 180 degree. But since these two angles are same, therefore this angle plus x, that is 2x equals 180, and therefore x equals 90. And then we can prove that diagonals in the rhombus bisect each other at right angle. Is that
So
clear?
can you go a bit slow?
Yeah, what happened?
But I didn't understand.
You didn't understand. Fine. See, show that if the diagonals of the quadrilateral bisect each other. This is a quadrilateral bisecting each other, the diagonals bisecting each other at 90 degree. Fine. If I say in triangle AOB and triangle COB, AOB and COB, I know that AO is equals to OC. Why? Given. Fine. After that, BO is equals to BO, common. Fine. They both are common. Also, angle BOA is equals to angle BOC. Sorry, angle BOA is equals to angle BOC. BOA is equals to BOC. Why they both are equal? Oh wait.
Each 90.
Yeah, each 90, yes. Now, if all of them are equal, then what we can say? That the two triangles are congruent by which test? Which test?
SAS.
SAS.
Yeah. By SAS test of congruency. Yeah. By SAS test of congruency. Now, once the two triangles are congruent, then what we can say? AB is equals to BC. AB is already equal to DC, and if AB is equals to DC, BC also, and AB is already equal to, so this all sides are equal, and therefore it is a rhombus.
That AB equal to DC.
AB is equals to BC, corresponding bicepticity.
No, that you told that AB is already equal to DC.
AB is already equal to DC. No, that is for the other two triangles. We are not considering that, no. We have
Okay.
taken this triangle and this triangle. Yeah. Now, if AB is equals to AC, the AB is equals to BC, then what we can say? That the two triangles bicepticity, and if the adjacent sides are equal in a parallelogram, sorry, if these two sides are equal, then what we can say? It is a rhombus. This side is also equal to this side. So all of them are equal, and finally what we can say? It is a rhombus. Clear? Okay.
Yes.
Next. But yeah, please try it on your own by yourself. The question number 4. Yeah. Please try it on your own. I'll be back in a minute.
The first part I've proved, second part I'm doing.
Okay. What about rest of the students? Please answer. Everyone can
Still
answer.
doing.
Doing. Okay. What about Ritika, Manasvi, Riva? What about you all? You are trying?
Yes, sir, try.
Okay. Now, what you have to do in this question, show that the diagonals of a square are equal. Fine. Let us draw one square. Now this is a square. Now what you have to prove that the diagonals are equal. Fine. If I draw these two diagonals, I need to show that the two diagonals are equal and bisect each other at right angles only. Fine. See over here. If this is A, B, C, and D, what is given in this quadrilateral ABCD is a square they have given. That's it. And what you have to prove in this? What do you have to prove? First of all, the diagonals are equal. That is, AC is
AC
equals
equal
to
to
BD.
BD.
This is what you have to prove. And the other thing which you have to prove is bisect each other at right angles. That means you can say angle AOB or any one angle is 90 degree. Or you can say AO is perpendicular to BD. Or you can say any one angle. That is the first. The second thing which you have to prove is angle AOB equals 90 degree. Fine. Any one angle, if you say 90 degree, all of them will be 90 degree. Yeah. Those are the two things you need to prove. Now let me take this square below to prove it. Now let's write the proof. Fine. If I take in triangle ADC and triangle BCD, what all things I know? AD is equals to BC. How? Opposite side of a square.
Opposite side.
Opposite side of square. The next thing is I can also say,
DC equal to DC.
yeah, DC equals to DC. How? Common. They both are common. After that,
Angle ADC equal to
yes,
angle BCD.
yeah, angle ADC is equal to angle BCD. Why? Each 90. Fine. Therefore, I can say triangle ADC is congruent to triangle BCD by which test?
SAS.
SAS. Perfect. I hope everyone is understanding this. Juhi, you will not answer
Yes.
henceforth anything unless I ask. Okay? Yeah? The two triangles are what? Congruent by SAS test of congruency. Yeah, the two triangles are congruent by SAS test of congruency. Over here, now since the two triangles are congruent, then what I can say? Then their diagonals are equal. Therefore, AC will be equal to BD. Why? Bicepticity. Hence, first one is proved. Yeah, the first thing, that is the diagonals are equal, that has been proved. The next thing is that they bisect each other at right angle. How you will prove it? Anyone over here? Yeah,
Sir, first we have to take triangle AOB and
and
triangle COD.
CO,
D.
COD. Okay,
And then angle BAO is equal to angle DOC by
fine. The
or
two triangles are congruent. The two triangles are what? It will be okay, fine. The two triangles are congruent. Chalo. Then
then angle AOB and angle COD are vertical opposite angle.
yes,
AB and CD are given.
yes,
Triangle AOB is congruent to triangle COD by AAS congruency.
fine.
And angle AO is equal to angle CO by CPCP.
Angle AOB or side AO.
Side AO.
Okay, then we need to prove angle AOB is 90 degree.
That's all I have done.
No.
Sir, can I
Anyone
take?
else? Yeah.
Sir, we will take triangle AOB and triangle BOC.
Perfect.
And then we can prove that triangle AOB and triangle BOC are congruent.
Perfect.
Therefore, angle AOB and angle BOC are equal by CPCT.
Yes.
So then we know that angle AOB plus angle BOC is 180 degree.
Perfect.
So therefore 2 into angle AOB is 180 degree.
Yes.
Therefore angle AOB is 90 degree. So
Perfect.
we can prove.
Perfect. Very nice. How many of you have understood what Dhruv said? Please raise your hands like this. Juhi, Manasvi, Riva. That's it? Fine. I will explain if you have not understood. So Nandini, Tanush, Ritika, Aryan, you did not understood? No? Fine. No problem. I will explain. See, what we will do, triangle AOB, we can say, in triangle AOB and triangle COB, right? What we know that is in these two triangles, what do we know? That is AB equals BC, side of square. Yeah, side of square. They are equal. OB equals OB. Why? Again, what common? What other thing we can take? AO equals
OC
OC. What will be the reason? Because diagonals of a square bisect each other. Yeah, diagonals of a
So that will
parallelogram,
be AC equal to BD, no?
they bisect each other. Bisect means what? They divide each other in equal parts. Got it?
So
Yeah.
can we say angle ABO equal to CBO?
ABO is equals to CBO. Yes, we can see. Because in a square, diagonals are also angle bisectors. Yeah. Over here, AO is equals to OC. Why? Because diagonals of a square bisect each other. Diagonals of a square bisect each other. Then what we can say? Therefore, triangle AOB is congruent to triangle COB. Fine. Now, once we know that the two triangles are congruent, again I'll take this. Wait. Yeah. Once we know that the two triangles are congruent, therefore, angle AOB will be equal to angle COB. Yes or no? By CPCT. Yeah, congruent parts of corresponding triangles. Clear? After this, we also know that angle AOB plus angle COB will be equal to 180 degree. Why? Linear pair. Yes or no? They are linear pair. Now, since those two angles are equal, no, so I can also say that angle AOB plus angle AOB will be equal to 180 degree. So twice of angle AOB will be equal to 180 degree. And then finally I can say angle AOB will be equal to 90 degree. Clear? How many of you it's clear? Please raise your hands. Yeah. The next. Show that if the diagonals of a quadrilateral are equal and bisect each other at right angle, then it is a square. Now again, it is a converse of what we have already done. If the diagonals of the quadrilateral are equal and bisect each other at right angle, then it is a square. So I'll try to explain it verbally. See, we have to prove that it is a square, no? So whenever you are drawing the diagram, take it as a square only. Okay. Also, the diagonals they said Now over here, while writing the proof, you don't know that it is a square. Don't consider that it is as a square, but while drawing it, make it as a square. Yeah. Now show that if the diagonals of a quadrilateral are equal. Now what they have given in this, if this is A, B, C, and this is D, what is given? The given thing is AC is equals to BD. Show that if the diagonals of a quadrilateral are equal and bisect each other at right angles, that means the one more thing they have given is that is AO equals OC and BO equals OD. They bisect each other. Also, one you can say angles are 90 degree. That is angle AOB is 90 degree. This all things they have given. Angle AOB, or you can also say angle BOC. Even if you write up to this, that is sufficient because this is 90, this will be 90, this is 90, this will be 90. That's why they are bisecting each other. You can also say AC is perpendicular to BD. You can also say it like this. AC is perpendicular to BD. I hope you are aware about this. You guys know this or you don't know? Juhi,
Yes.
know
Yes.
it?
Yes, sir, we know.
Okay, fine. Okay. Now what you know in this is angle AOB and angles BOC are 90 degree they have given. You have to prove that it is a square. Now when you will know that it is a square?
Interior angle, all are 90.
All are 90. So even if you prove that it is a means all the sides are parallel, and if you prove that one of the angle is 90 degree, then it is a square. Fine. Now this side is equal to this. This is common. How you will prove?
So we can take triangle AOB and AOD.
Yeah. Then if I take triangle AOB and AOD, oh fine. So what I know, only this side is common, this side is equal, and what I know,
Angle AOB equal to AOD.
angle AOB equals AOD. How? Yeah, it is given, no?
Yeah.
The diagonals of quadrilateral and equal and bisect each other. Yeah, we can do that. So in triangle AOB and triangle AOD, what do we know? AO equals AO, common. Yeah. BO equals DO, given. Given. Also, angle AOB equals angle AOD, each 90. Why? Each 90 degree. Now if this is done, then the two triangles are congruent. Therefore, triangle AOB is congruent to triangle AOD. Now if the two triangles are congruent, then AD is equals to AB. Yes or no? AD will be
Yes.
equal to AB by CPCT. Yeah. Now I got it that AB is equals to AD. Now next, I can also take
Sir, we can also say that
AOB
angle
and
DAO equal to BAO. CPCT.
what?
Angle DAO equal to angle BAO. And then by linear pair.
Then by angle DAO, this and angle BOO, yeah, they both are equal. Then what? What will be the use?
Sir, I thought it was linear.
No, it's not a linear pair. For a linear pair, it should be in the straight line. Means this should be the line and this should be the line, and this angle are linear pair. Okay. Now the next thing which you can take is triangle AOB and triangle DOC. Triangle AOB and triangle COD. What do you have? AO equals OC given. Again, BO equals OD again given. Yeah, BO equals OD and what is left? AO equals in triangle AOB and COD. Yeah, and then opposite angles are equal. Angle AOB is equals to angle DOC. That is vertically opposite angles. That is sufficient. Even 90-degree, but vertically opposite angle is also sufficient. Then what we can say? Therefore, triangle AOB is congruent to triangle COD by SAS test. Then what we can say? Therefore, AB is equals to DC. Now, we in the previous one we proved that AB equals AD. If AB equals AD and AB equals DC, this all these three sides are equal. Similarly, we can prove that AB equals BC. Therefore, all the sides will be equal. Similarly, we can write over here. Similarly, AB is equals to BC. Therefore, if this is 2, this is 3, and that was 1. From 1, 2, and 3.
Sir,
Yeah.
so but to prove square, you have to prove that angles are 90
Yeah, yeah.
degrees.
It's not completed. Did I say that it's completed? It's
Okay.
not completed. We have proved one part of it. That is, all sides are equal. That is, one part is required for a square. That all sides are equal. Now, what you need to prove is, one of the angle is 90-degree. Now, how you'll prove? See, we know that this triangle is congruent to this triangle. Where it is? Yeah. This triangle is congruent to this triangle. That means this angle, if I say this angle is x, if I say this angle is x, this angle will also be x. Similarly, this triangle is similar to this triangle. If this is x, this is also x. Wait. This also, these two triangles are also similar, no? AOB and DOC. Congruent, no? So this angle is also equal to this angle. And if this angle and these two angles will also be equal, so this angle x. So x plus x plus x plus x. That is, since it's a no, we cannot say. Opposite pairs are not. Wait, no. How you will prove that it as a 90-degree? Wait,
The
wait.
triangle ADC and BCD.
ADC and BCD. What we will do
If
in
we
that?
prove them congruent.
Then
Uh,
then the
so
diagonals will be equal. Yeah, perfect.
no.
Perfect, perfect. That's the answer. Then the diagonals will be equal. Yeah. Then AC will be equal to BD. Then half of AC will be equal to half of BD. Half of AC is this side, and half of BD is this side. Right? That means these two angles are equal. That means this angle and this angle are equal. If this is 90, so this x plus x will be equal to 90. So each x will be equal to 45. Similarly, we can do in this triangle also. This will also be equal to 45. And if you both add both of them, then it will be 90-degree. And therefore, we can say that the two triangles, therefore, it is the square. Did you understood how 45?
Sir,
Yeah.
sir, we can also prove like a triangle ABC and a triangle ADC are congruent. So
ABC and
then
ADC. ABC and ADC. Yeah.
are congruent. So then
Yeah.
we can say
That.
that angle ABC and angle ADC are equal.
Hmm.
So then ADC and sorry, ADC is equal to 90 degrees.
How? If they are equal, how 90?
Sir,
Hmm.
sir, I was saying that can we say that angle A, if we prove triangle ADC and triangle BCD congruent, then
Hmm.
can we say that angle ADC plus BCD is 180?
Yeah.
So that
Yeah,
way only we can prove.
that will also be easy. Yeah.
Yeah, so I was
The
saying
two
that.
triangles are congruent. Then what we can, since ADC and BCD, but no, we cannot say it because it's a quadrilateral, no. No, wait. Once we prove that all the sides are equal, then what we can say? It is a rhombus or parallelogram.
Hmm.
Yeah, it can also be said as a rhombus since all the sides are equal. And since all the sides are equal, it's a rhombus. Therefore, again, if ADC plus BCD equals 90 degree, if they both are equal, then ADC plus BCD should be equal to 180 degree. And therefore,
The reason what we can write.
because ABCD is a rhombus. See, if this is there, what we can say, therefore, quadrilateral ABCD is a rhombus. It has to be a rhombus, no? For a rhombus only, this is the criteria. All the sides should be equal, not 90 degree. Only this is the criteria that all the sides should be equal. If it is a
So if
rhombus,
it is rhombus, then
then the opposite sides are parallel.
adjacent angle will be
Yeah,
180.
sum of adjacent angles should be equal to 180 degree.
Okay.
Yeah, then the two angles are equal. Then what we can say?
Two angle
It will,
ADC is 180.
yeah, two angle ADC is 180. Therefore, angle ADC will be equal to 90. Understood?
I got it.
Okay. Since we have less time left, that's why I have completed the last part in a short way. Even if you have any confusion, we'll do in details in the next class. Okay. Chalo then. Bye for now. I hope you
Bye,
all
sir.
have understood properly. This was your first class, all of you with me. How was it? You want me to go with this speed, or you want me to go even more speed, or I have to decrease the speed? What do you want?
Sir, this speed is okay.
The speed is okay. Everyone, I want
Yes.
responses from everyone.
Yes.
Yeah, Manasvi, Nandini, it's fine. You can give a thumbs up like this if you want to say everything is okay. Everything is fine. Okay. Chalo then. Bye. Bye, everyone. Have a good day.
Bye, sir.
Yeah.
Bye, sir.